Hello everyone and welcome to the Kubernetes CKA Mock Exam 3 solution section. My name is Vijay Balaji and in this section we will attempt to solve the questions together. Okay, to start off, let's click on the exam portal, and this is the mock exam 3, and this consists of 9 questions total, and just like the previous mock exam, this is graded out of 100%, out of which you have to secure 74% to pass this mock exam. Okay, so let's start off with the question number 1. And the first one is create a new service account with the name PVViewer. Grant this service account access to list all persistent volumes in the cluster by creating an appropriate cluster role called PVViewer role and cluster role binding called PVViewer role binding. Next, create a pod called PVViewer with the image Redis and service account PVViewer in the default namespace. So there are about 3 to 4 tasks that we need to do. The first task that is to be accomplished is to create a service account by the name of PVViewer. And let's go to the Kubernetes documentation just to see how a service account can be configured for a pod. So if you go to Kubernetes docs tasks, configure pod container, configure a service account, you'll see a pod description where you can create a service account name. So basically, in this case, we are creating a custom service account and we are using that service account name to be used when a pod is created. By default, a default service account is created for every namespace, but in this case, we are creating a custom one. Okay, so let's create the PVViewer service account first. So for this, we can use the imperative way. Quickly, I'll just run through the environment first. So this is a large cluster. It has 4 nodes in total, 1 master and 3 worker nodes. So that's the first task out of the way. So it has created a service account called PVViewer, and since I'm not specifying a namespace, it'll create it in the default namespace. The second task is to grant the service account access to list all persistent volumes. So we have to create a cluster role, and the name of it has to be PVViewer role, and we have to create a cluster role binding, attaching that role to the service account, and that's to be called as a PVViewer role binding. Okay, so let's do that now. And we can make use of the imperative way again to create the necessary cluster role. I'll just copy the name from the question so there are no typos there. And the resource in this case is persistent volumes. And the verb is list, and that's highlighted here. So the PVViewer role is created. And next, let's create a cluster role binding. Again, I'll copy the name from the question. The cluster role is the one that we created in the previous step. So we'll copy it from here. And in this case, it has to be the service account instead of a user. Now there's a trick to this. We have to specify the namespace as well. So if I just give PVViewer, it will complain of an error saying that service account must be in the format, the syntax namespace followed by the name. So I should add default here. And now it should have been created. So there you go. The next task is to create a pod which can make use of the service account, and Let's read the last bit of this question again. So next, create a pod called PVViewer with the image Redis and service account called PVViewer. Okay, so for this, I'll create a template first. So now that the template has been created, I'll update it to make use of the service account. So now let's go back to the Kubernetes documentation, and as you can see here, the parameter that we have to add is service account name. I'll just get rid of these additional parameters which is not needed in this case. And in this case, you don't have to specify the namespace name in the service account name. That will be taken care by default when you create the pod, depending upon the namespace that it's deployed in. Now let's create the pod. Now the pod is created. Let's just quickly check whether it's created according to the question. So that's a container. And here it should have a secret name, and that is created with the name of the service account. So that's one way to make sure that the question has been attempted correctly. So whenever a pod is created, a default service account is associated with it, and a token is created with that specific service account as a secret, and that's the one which is mounted on a pod. So in this case, we created the service account as PVViewer, and hence you can see the name here reflecting PVViewer. So that's the first question out of the way. Let's move on to the next one. All right, let's go to the next question now. The second question is, list the internal IP of all nodes of the cluster. Save the result to a file called as /root/node_IPs. Answer should be in the format internal IP of master space internal IP of node 1 space internal IP of node 2 and space finally internal IP of node 3, all in a single line. So this is a JSONPath specific question, and just let's jump to the Kubernetes documentation and see a reference example. So if you go to the kubectl cheat sheet page here, you'll see a lot of examples for JSONPath, which is quite handy. And let's go to the specific one here, get external IPs of all nodes. So here we are running kubectl get nodes -o JSONPath, and here for all items, status address, and for the type external IP, list all the addresses. So in this case, specific question, we do not have an external IP, we have an internal IP. So we can replace this whole exercise with just replacing the external IP with internal IP, and that should give us the required result. So let's copy it from here. Before we save it, we'll just run it as it is, and this should return up empty. So as I said, we do not have an external IP for this cluster, so let's replace that with internal IP. And as you can see, it gives you the space separated internal IP for all the nodes. So 172.17.0.16, 172.17.0.19, 24, and 28. So we can redirect the output to that specific file. Another way to check is because we just have an internal IP, you can remove the entire contents of this search here. and that should return you the same thing, because in this case we only have internal IPs. We do not have any other type of IPs as part of this array in the address here. So even without a specific type that we are searching for, internal IP or external IP, it should still return you the correct answer. So let's quickly verify that the answer has been recorded. So that should be it. We can mark this question complete and move on to the next question. Okay, so let's move on to the third question. This is an easy one. This is to create a pod called multipod with two containers. Container 1 name is alpha with image nginx. Container 2 name is beta with the image busybox, and it should run a sleep command for 4800 seconds. And each of the container have environment variables that we need to define for the pod. Okay, so let's go to the terminal. The easiest way to do this is to make sure that we have a template file first. So let's create that. You know that the first container name is alpha and the image is nginx. I'll redirect this to a file called as multipod.yaml. Now that's done. Let's edit the settings as needed. So the name of the container itself should be multipod. We don't need any labels here, so I'm going to remove this. The image is correct, the name is also correct. I'm going to remove the other bits here. We know that this has an environment variable that we need to define, and the name and the value is alpha for the name as name. Now that's the first container done. Let's create the second one. For this, let's busybox. Name is beta. This should be running a command. For 4800 seconds, and we also have to define an environment variable file. This one, the environment to be defined is name as name and value as beta. Let me double check. That looks all right. The name is multipod. Don't need any labels. It's not specified in the question, so I'll remove that. The container 1 is alpha with the image nginx. It has got an environment here. The variable is alpha. That's a key value pair with the name, which incidentally is also name. The value for that is alpha, and similarly for container 2, the name is beta using the image busybox, running a command sleep 4800, and the environment similar to the previous one, name as name, value is beta in this case. So let's create this pod. Let's run a kubectl describe. And make sure that two containers have been created and are in running state. So it's still in container creating state. Let's run it again. So container beta is running. It's running the sleep command here. It has got the environment definition underneath. And similarly, alpha container is also running. It has got the environment described here. So that looks good. Just making sure that the name is right and everything is in a running state. Okay, so that's this question out of the way. Let's move on to the next one. Okay, so the fourth question, we have to create a pod called lion with image redis alpine. Set the CPU limit to 2 CPU and memory limit to 500 MIB. So this is a resource specific question and we are supposed to set limit. Okay, so let's go back to the terminal, and for this we can make use of one of the templates that we used before. So I'm just going to use that. Just copy the template that we created for the very first question into a file called lion.yaml. Again, we don't need any of these in this specific case, so I'm just going to replace the name to lion, and the image is redis alpine. We don't need a service account in this case, so I'll just get rid of that. And let's jump to the Kubernetes documentation to see how limits are configured. So if you go to the docs concepts and how pods with resource limits are run, you can see an example here where a resource section has been defined with both requests and limits. In this case, we don't have to specify the request field, just ask for a limit, so we'll just do that. So it's under the container definition here, and you can see that we have to create resources and limits. So to CPU, memory should be 500. That should be it. Let's create this pod. The pod has been created. As always, let's run the kubectl describe pod, the pod name, to make sure it's been created properly and it's in a running state. So it is in a running state. The name is lion with a container called as lion as well. And here are the resources. So limit set to CPU is equal to 2 and memory is equal to 500 MI. So that's this question out of the way. We can move on to the next question. Right, so let's get started with this question number 5. We have deployed a new pod called np-test-1 and a service called np-test-service. Incoming connections to this service are not working. Troubleshoot and fix it. Create network policy by the name ingress to np-test that allows incoming connections to the service over port 80. Important. Do not delete any current objects which are deployed. So this is a network policy related question. So looks like a pod has already been created, which is exposed using a service, and looks like the connections, that's the ingress connections to this service, is not working. So let's check that first. Okay, so let's check the pod itself first. And there is a service that's created here called as np-test-1. And that has a label called as run np-test-1. And which image is it running? So it's running nginx, and that's about it. Let's check the service that has also been created by the name of np-test service. And as you can see, that one is actually routing the connection to the pod with the label run is equal to np-test-1. That's the pod that we just checked out a minute back. And that has one endpoint, which is the pod itself, and it's running on the container port 80. Now let's test the connectivity for incoming connections, incoming traffic into that particular pod using the service. So for this, we can use a busybox container and test the connectivity using netcat or telnet. So let's create that pod first. Let's call it as test np network policy with an image of busybox 128. We want the container to be removed once we run the check. Let's run a shell session into the container. So we'll run a netcat command nc-z-v-w2 for 2 iterations, and we know the name of the service is np test service, and that runs on port 80. So as you can see here, the connection has timed out. So it looks like the ingress traffic is not working from within the same namespace. So let's see why that is. So if we run kubectl get netpol, which is the short name for network policy, we should be seeing a default deny here. So let's run a quick lookup on this network policy and see what it does. So this is running on the default namespace. The name is default deny. The pod selector is none, so allowing the specific traffic to all pods in this namespace. And so it is affecting all pods within the default namespace. And if you see here, allowing ingress traffic, none. So it is not allowing any ingress traffic. So all pods are isolated for ingress and as well as egress in this case. But the policy type that we have specified is ingress. So all incoming connections are blocked. So in order to fix this and make sure that the NP test service is accessible from, for example, a busybox pod, which is also created in the same default namespace, we'll have to create another namespace and permit that particular connection specifically. So let's do that now. So let's check the Kubernetes documentation first and check what it's got to offer. So if you go to kubernetes.io docs concepts and network policies here, you'll see a lot of examples for network policy resources as well. So in this specific case, there is a network policy created called test-network policy, and that is applied to a specific pod, which is exactly what we need to do here. We want to make sure that the pod called as np-test-1, which is exposed via the service, is actually accessible for any ingress traffic. So we have to apply a pod selector here, and we have to make sure that the correct labels are configured so that it targets the correct pod. And in our case, the policy type should be ingress, so we will not use egress as shown here. And for ingress, we'll have to make sure that the connections from all the pods are open and all the sources are available, and it hits a specific port on that specific pod, and we know that it runs on port 80 because it's running an nginx based image. So we will configure the port as port 80. The remaining things are not applicable here because we don't have a namespace or an IP block specific range that we want to restrict or allow. So in our case, we would only be using a pod selector, and this will also be a blank statement because we want it to work for all pods. So we will remove all of these and just specify the ports field here. And once that's done, we'll test again to make sure that the connectivity is working. Okay, so to begin with, let me copy some of the lines from this network policy file, and then we can create one of our own. So I'm going to call this file as np.yaml. And again, let's make use of kubectl API versions. And if you Check for network, that's the correct API version, so it should be networking.kas.io, which is what is being defined here as well. Just make sure the name is created as per the question. Just copy it from there. So the name is ingress to np test. And under the spec field, we have pod selector. And if you remember correctly, the label for that pod is run with the value np test. So you can take it from here. So the pod selector definition is complete. Now we have to specify the policy types. So in this case, we are just going to make use of ingress. And following that, we'll define the ingress specification. And as I mentioned before, we have to make sure that the incoming traffic works from all pods within the default namespace. So we are not going to specify any of these here. No from field, because it should be from all. So we will not specify any of these. The only thing that we have to specify is the port. So we can copy it from here. So that looks all right. It's applied to the correct pod, ingress policy alone, and we have specified the port. Let's create this network policy. So that has been created. Now let's do the same exercise as before. I'm going to run this temporary pod called as test np again and execute into the shell. And let's run the netcat again. So nc-c-v-w2, copy the service name from here, and the port should be 80. So there you go. Now it's accessible, it's open. So that means that the network policy that we configured is working properly, and we didn't have to delete or modify any of the existing objects, which was one of the prerequisites. So important, don't alter any existing objects. Network policy applied to all sources, incoming traffic from all pods. Network policy is using the correct port because you have specified port 80, and it is applied to the correct pod because you use the correct label with the name np-test-1. So that should be the answer for this specific question. Let's move on to the next one. Okay, so let's move on to the next question. This is question number 6. Take the worker node node01 to be unschedulable. Once done, create a pod called dev-redis with the image redis alpine to ensure workloads are not scheduled to this worker node. Finally, create a new pod called prod-redis with the same image with the toleration to be scheduled on node01. And here are the specs. So the key is env underscore type, value is production, and the operator is no schedule. and we just have to make sure that the node 01 is tainted, and then create a pod called dev-redis without any toleration, and another pod called prod-redis which has a toleration, so it can be scheduled on node 01. Okay, so let's go back to the terminal. So the first thing to be done is taint the worker node. So let's check the environment again. So kubectl get nodes. There are 3 worker nodes, out of which we have to taint this node 01. So let's do that right now. Kubectl taint node 01, and let's take the specification from the question. So the key value pair is env type is equal to production, and the effect is no schedule. We'll just copy it from here. So node 01 is tainted. We can run kubectl describe node 01 and grep for taint, and you should see that here. So env type production, and the effect is no schedule. So that's the first part of the question which is completed. So for the second part of the question, we have to create a pod called dev-redis and with a specific image, and we'll see if it's able to start on node 01. Copy that again. That's about it. So the dev-redis is created. Let's run kubectl get pods -o wide, and dev-redis, as you can see, is running on node 03. So because this does not have a toleration, it should not be scheduled on node 1 at any point of time, and that's what we will try to attempt next. So we'll create a toleration for the pod, which is called as prod-redis, and the toleration should allow it to be scheduled on node 01. Doesn't mean that it has to necessarily go there, so the scheduler might decide to put it elsewhere, but it should have the ability to be scheduled on node 01. So let's create the prod-redis pod next. So back to the terminal. I will get the pod that we just created called as dev-redis and redirect that to prod-redis. Now let's edit this file. The name should be prod. And I'll remove these sections here which are not needed. And since we did an export, you can see that there is a toleration field here which we can make use of. So in our case, the effect is no schedule. The key is, let's go back to the question. The key should be env underscore type, the environment type. The operator should be equal. We need the toleration seconds. We need the value. And in our case, the value should be production. So let's confirm that everything is configured correctly. The name should be prod-redis. and the image is Redis Alpine, and the toleration is for key env underscore type, the value is production, operator is equal, and the effect is no schedule. So let's create this pod now. Pod is created. Let's run this again. And in this case, the pod is created on node 02. So as I said, it does not necessarily mean that the pod will only be scheduled on node 01. It means that it can be scheduled on node 01 because it has got a toleration. So in any case, the scheduler has decided to put this on another node, but that's okay. So let's move on to the next question because this one is complete. Okay, so this is question number 7, and we have to create a pod called HR-pod in the HR namespace belonging to production environment and front-end tier. So these are labels. Image should be Redis Alpine. So use appropriate labels and create all the required objects if it's not existing in the system already. So HR pod label with environment production, HR pod label with front-end tier. Okay, so let's go back to the terminal. So first thing to check is if there is a namespace called as HR. So as you can see, it does not exist. So let's create one. So now it has been created. Next step is to create a pod. Let me clear the screen. Name is HR-pod, and the image is Redis Alpine. I'll just copy it from the question. We've got two labels to be created. So the environment is production. These can be done with a comma separation, and the second one, the tier is equal to front end. And I missed to specify the namespace here, so let's delete that pod from the default namespace and recreate it with the correct namespace. So let's run the kubectl-n, the namespace HR, get pods with the labels. So HR pod is running, and we have the correct label set. So this is an easy question. Everything has been completed. The pod has been labeled with two labels. One is environment is equal to production. The other one is tier is equal to front end. We created the namespace first, and then it's using the correct image. So this one is complete. Let's move on to the next one. Okay, so this is the question number 8. And for this one, a Cubeconfig file called super.cubeconfig has been created in /root. There is something wrong with the configuration. Troubleshoot and fix it. So let's go back to the terminal here. So by default, we have a kubeconfig file which is created under the hidden directory called as .cube/config, and that's what all our commands use. So when I run kubectl get nodes, it's basically using the config file which is created under the .cube directory. So if I just get this particular file, you'll see that the user for this configuration is Kubernetes-admin, and the cluster which is created is called as Kubernetes. So the context name that we are using is Kubernetes-admin at Kubernetes. And if you scroll up, you'll see the details of the cluster. So for the cluster, the server name, which is the Kube API server, is this particular URL, which is HTTPS, and the IP address of the master node, followed by the Kube API server port that it listens to, which is 6443. And here there is the CA certificate as well. So now let's go back to the question. And it says that a super.kubeconfig has been created under /root. So let's go to /root. And here is the kubeconfig. So let's try to run a command using that specific kubeconfig file. So cluster info -kubeconfig, so that we can override the default kube configuration file and specify this one. So as you can see here, there is an error that it says the connection to the server was refused. Did you specify the right host or port? So straight away you can see that the port that it's using seems to be incorrect. This is 2379, which incidentally is the one which is used by the HCD, but not the Kube API server. So we have to correct that. So let's go to the file. And this is using the same context, the Kubernetes -admin at Kubernetes as the context, where the user is Kubernetes-admin and the cluster is Kubernetes. So here you can correct the port. Let's change it back to 6443. So remember that for kubeconfig, we don't have to apply any changes or use create or apply. This is a static file and doesn't have to be created. So the contents within this is read by kubectl, and there's no other action that's needed in this case. So let's try to run that command again. And this time it's able to return all the correct values. So the problem with that file was incorrect port, and we have fixed that. Is there anything else to be done? No, it's just fixing the kubeconfig file. So it's a very simple question. Let's move on to the next one. Right, so we have reached the final question of this mock exam, and then we should be done with this. So let's finish this. We have created a new deployment called nginx-deploy. Scale the deployment to 3 replicas. As the replicas increase, troubleshoot the issue and fix it. So the deployment has 3 replicas. That's the end goal. Let's go back to the terminal and check this deployment. So we have a deployment called nginx-deploy. Let's try to, it's up to date as of now. So let's try to scale this. So that has been successfully completed. Let's run the command again. So desired is equal to 3 and current is 1, up to date is 1, available is equal to 0. So there definitely seems to be something wrong with this deployment. Let's run a describe. So the describe also says the same thing about the replicas. The number of replicas desired is 3, 1 updated, 1 total, 0 available. Let's scroll down, scaled up the replica set to nginx-deploy, and that's the pod name, and that's just 1 replica set at this point of time. So let's try to see the pods. And as you can see, that's the single pod that's created out of this deployment and the replica set, and we do not have 2 additional ones which were created based on the scale command that we used. So now the next logical thing to be checked is the control plane components, which reside under kube system namespace. And if you see the status of the control plane components, you can see that there is an error for the controller manager pod and image pull back off. So let's try to investigate the root cause for this failure. So we know that the control plane components in this case have been created as a static pod. The easiest way to figure that out is that it's appended by hyphen node name in the end of the pod, and in this case this is running on the master node. You can see that Cube API server, Cube controller manager, Cube scheduler, and HCD are all static pods because they have hyphen master at the end, which is the node name of our master server. So let's go to the default static pod path, which is a etc Kubernetes manifest file, and let's check the contents of this file. So now if you look closely, you'd see that the word controller is misspelled. So instead of control, there is a 1 here, and that seems to be replicated everywhere. So the name is controller with a 1 instead of L. The command that uses is also of the same mistake in the name and any other place. How about the image? Yes, the image name is also incorrect. So let's correct all the places in this file where we have a typo and correct it with by replacing the 1 with an L. So there are two ways you can do that. Either replace all the mistakes which are there in the file by editing it with a text editor such as VI, or we can use a sed. So just to make it easier, I'm going to use a sed command. It's not necessary to run this, but makes things a little easier and quicker. So sed-i substitute. So I'm just going to copy this and change it. We know that the mistake is a 1 instead of an L. So the image is not found, which is why when we check the status of the control plane components, it complained of unable to pull that specific image. So I'm going to substitute all incorrect instances of this particular string in the file. So before I do that, let me just quickly check. As you can see, this is wrong in 5 different locations. One is the component, the name itself, the command that it's running, and the image, which is the main thing because it's not able to pull that specific image. So let's run that sed command. As I said, you can replace this individually on the file itself. This just makes it a little quicker. So that should be done. Now it should be 0. And let's check the status again. So now looks like it's back running again. So Cube controller manager, the name is correct and it's running 10 seconds ago. So that's good news. Now let's check our deployment. So now as you can see, the number of available replicas has increased from 1 to 3. Let's check the pods. And you can see that about 17 seconds ago, 2 new replicas were also created. So the issue was with the Cube Controller Manager not running. So the replica sets were not created because that's controlled by the Cube Controller Manager. And as soon as we fixed it, it's intelligent enough to know that it needs 3 total replicas as its desired configuration, and it went ahead and created 2 more. So that brings us to the end of this exam. Let's mark this exam as complete. and let the testing begin. And hopefully we have attempted everything correctly, and we should get our results pretty quick. So there you go. All the questions have been graded, and we have done all the questions correctly. So we've got 100% score. So thank you everyone for joining me on this section, and I hope you enjoyed it. Bye.